Assalamualaikum warahmatullahi wabarakatuh and good morning to our lecturer Dr. Radiah binti Muhammad. So today we are from group 14 and we're going to present our project which is called Relationship between Daily Gaming Hours of University Students and Academic Grades. So this is our team. We have Azhar Mukris as our leader and we got Ezekiel, Musa Al-Kazim and me, Muhammad Imam Kain and Aiman Afiq Azman. So for the introduction, this project investigates the relationship between daily gaming hours and academic performance among a sample of 200 students. So for the purpose is does the amount of the university students spend gaming each day nearly impact the academic grades of GPA. So we want to test out our hypothesis. The more you gaming, the worse your GPA academic. So our expected finding is a significant linear relationship where excessive digital leisure actively trades off with academic focus. For the rationale with a rapid expansion of modern gaming platform, all the academic studies are outdated. These studies provide crucial data-driven insight to help balance student well-being, parental guidance, and digital literacy within our university community. So for the problem statement, people continue to be concerned about the negative effects on gaming on student academic performance. Existing research into the relationship between gaming and academic has concluded various results. This research is to determine the significance of the gaming hours and grades. So for the variables breakdown here, for the independent X, which is daily gaming hours, for the justification, the core predictive variable testing if variation in gaming time expenses in performance. For the dependent variable, which is Y, we determine is as the academic grades or GPA. For the justification, the response or the outcome variable hypothesized to be affected by daily gaming duration.
Assalamualaikum. My name is Muhammad Musa Al-Kazim bin Abdul Majid. So for my part is methodology and sampling strategy. So our study uses a quantitative correlational design to examine the linear relationship between daily gaming hours (SX) and academic grade (SY) among the university students. We choose correlational because we are testing whether these two existing variables move together and not running a control experiment where we manipulate anything ourselves. As you can see here, we use the secondary dataset from Kaggle University, which is Gaming Academic Performance.csp. Rather than running our own survey, this lets us work with a much larger ready-made sample instead of spending time collecting response ourselves. So for the sampling, we extract first 200 student records using Python's pandas libraries. As we can see here, it is 5 times the cost minimum, which is 40 observation, which gives us a strong, well-powered sample for the analysis. And for our analysis environment, we use Python 3 within the Jupyter Notebook, Pandas for the descriptive statistics, stats model for the OLS regression, and Matplotlib for the scatter plot. This lets us calculate our regression manually and independently verify it against software, which was a direct requirement of the project. That's all for me. I will pass it to the next presenter.
Assalamualaikum, and my name is Aiman Afiq bin Azman, and I will talk about a descriptive statistic. Before we get into the regression model, let's look at the basic shape of our data. We collected data we get the data about 200 students looking at two variables: how many hours they game per day and their academic grades. On average, students in our sample game about 4.12 hours a day, with grades ranging quite widely. The average grade was 66.47. What's really interesting here is the spread. The standard deviation for gaming hour is 2.36, meaning our sample includes everyone from students who game almost 0 hours a day up to student gaming a full 8 hours daily. That's a huge range. So we are capturing both casual and heavy gamer. Grids show even more variation. A standard deviation of 22.74, which scores ranging from as low as 8.97 up to 109.08. That tells us academic performance in this sample isn't clustered tightly around the average. There's a lot of variability we need to explain. So the key takeaway from this slide is we have a genuinely diverse sample in both gaming habit and academic outcome, which set us up well to test whether these two variables are actually related or not. I will pass to my
Okay,
friend.
firstly, for this section, I'll walk through the manual calculation and correlation analysis. Before we could calculate the correlation and coefficient manually, we first needed to compute the summation totals from samples of 200 students. So as shown on the table, we calculated the sum of X, which is total gaming hours, coming into 824.23. The sum of y, which is the total grades, which is 13,293.52. And we also computed the sum of x squared, the sum of y squared, and the sum of xy, which is all came to 4,508.37, 986,467.72, and 48,333.71, respectively from all x squared, y squared, and some xy. These six values are essential because they are a form of building blocks for our both Pearson correlation and coefficient, and later for our regression
Using
equation.
all
These summation totals, we applied the Pearson correlation coefficient formula where R equals n times sum of xy minus sum of x times sum of y, where all the divided by the square roots of n times sums of x squared minus sum of x squared multiplied by the n times square of y squared minus sum of y squared. By plugging in all the numbers of our value, we got an R of negative 0.6032. This tells us the two things. First, the direction. It is a negative, meaning gaming hour and academic grades move in the opposite directions. The second is the strength. The value of 0.603 falls in the moderate range. So, in simple terms, as students spend more hours gaming per day, their academic grades tend to decrease. This will, and their relationship is fairly consistent across our sample of 200 students. So this correlation result set up the next parts of our analysis, where we use the same summation totals to derive the regression equation.
Now that we confirm a correlation exists, so now we move on building a predictive model, the simple linear regression model, to actually quantify that relationship. Using the least square method, we manually calculated two coefficients, a slope of negative 5.8 and an intercept of 90.38. Putting those together give us our regression equation. Y equal to 90.38 minus 5.8 times x, where x is daily gaming hours and y is the predicted grade. Okay, let's break down what these two numbers actually mean. The intercept 90.88 represent the baseline. Is the predicted grade for a student who games 0 hours a day. They don't play a game anything. They don't play anything. The slope is really the headline finding here. For every additional hour a student spend gaming per day, their predicted academic grade drops by about 5.8 points on average. So if we compare a student who doesn't game at all versus the one who games 4 hours a day, this model predicts roughly a 23-point difference in grade, which is meaningful gap. This gives us a concrete, quantified way to describe the negative relationship we saw in the correlation. rather than just saying gaming and grades are related.
Assalamualaikum warahmatullahi wabarakatuh. My name is Azad Mukris Birizalman. Now I'm going to explain the software verification and model fit. To verify our manual regression, we ran the same data through Python software. Our hand calculated intercept was 90.3838 and slope is negative 5.8033. It matched the software exactly, confirming our calculation were correct. The model's R-squared is 0.364, meaning gaming hours explain about 36% of the variation in grades. And with a p-value of 0.00, well below our 0.05 threshold, we reject the null hypothesis, which the relationship is statistically significant. Next, we are moving to the next part, which is visualizing and forecasting grades. This scatter plot shows all 200 students with the red regression line. Y hat is equals to 90.38 minus 5.80x, capturing a clear downward trend, more gaming hours, lower grades. Using this equation, we can forecast outcomes. A student who doesn't game is predicted to score 90.38, while a student gaming 8 hours a day is predicted to drop to just 43.96. Overall, we found a moderate negative correlation, R equals to negative 0.603 between gaming hours and grades. Gaming explains part of the picture, but the remaining 64% come from other factors like study habits and sleep. And this match findings in prior research on gaming and academic performance. Since our study is correlational, we cannot claim gaming causes lower grades. Only that the two are statistically linked. We successfully quantified the correlation, built a verified predictive model, and visualized the trend. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. That's all from us. Thank you.